Good morning, students. Myself, Dr. Shantani Bhattacharya, Assistant Professor of EC Department, SRM Institute of Science and Technology, Katankulatu, Chennai. Today, I am going to start a new topic: binary code converter. Okay. So, first of all, what is BCD? BCD is actually binary coded decimal. So, we have to convert this BCD number to the decimal number. So, first of all, digital circuit, it is actually a digital circuit that can convert the binary coded decimal number into an equivalent decimal number is referred to as BCD to decimal converter. Okay. So BCD to decimal converter takes an 8421 BCD code as a input and generates a decimal number as a output. Here actually in the input section basically there are 4 input and in the output section we will get 10 outputs. Okay. So here B3, B2, B1, B0 are the inputs and these are basically the output. So we have taken first of all 0 to D0 to D9 number. All this number we will represent as a 4-bit binary number, and all of you know this 8421 combination. If you don't know, then if you go to my previous videos where I have already mentioned how to represent any actually decimal number in the form of 4-bit binary number. Okay, so D0 we have to represent 0000, then D1 0001, D2 0010, because this is 8421 combinations. We have already written all these things. Okay, D3 is 0011, D4 is 0100, D5 is 0101, D6 is 0110, D7 0111, D8 1000, D9 1001. So here if I represent D0, it is basically B3 bar, B2 bar, B1 bar, B0 bar. Then D1, B3 bar, B2 bar, B1 bar, B0. D2, B3 bar, B2 bar, B1 and B0 bar. For D3, B3 bar, B2 bar, B1 and B0. Then D4, B3 bar, B2, B1 bar and B0 bar. For D5, B3 bar, B2, B1 bar and B0 bar. D6, B3 bar, B2, B1 and B0 bar. D7, B3 bar, B2, B1 and B0. For D8, B3, B2 bar, B1 bar, B0 bar. D9, that means B3 bar, B3, B2 bar, B1 bar and B0. Okay, so these are basically the logical expressions of this decimal numbers. So here these are this is the circuit diagram. So here B3, B2, B1, B0 are the input and these are D2 to D9 are the input, and based on these combinations this circuit diagram is already drawn. So now we are coming to the next part, binary to gray code converter. Okay, so this is a very common question. Basically in the short question in any exam you have seen some binary code they have given to you, they tell you that you have to convert it in a gray code. Okay, so what is the process for converting binary number to gray code number? So this is B3, B2, B1, B0. As it is a binary number, so here I have written B in the form of B. Okay, so I didn't mention here any binary number, that means in a 0-1 combination I didn't give. Here I only explain the process. Okay, so as it is a gray code, so I have written as G. Okay, so when there is any 4-bit binary number, it will be 5 bit, 6 bit they can give you, same process you have to follow. But for 4 bit number, first of all, in the MSB you have to directly write the same binary number for gray code also. Okay, then for G2 you have to do the XOR between B3 and B2, and for G1 B2 XOR B1, for G0 B1 XOR B0. Okay, now coming to the circuit diagram. Circuit diagram means that is B3 we have to directly write for G3, so B3 directly write G3, then B3 XOR B2 to get the G2, then B3 and B2 we have to pass through a XOR gate, we will get G2. Okay, then B1 XOR, that means B2 XOR B1, we will get G1. That means there is a B2 and there is a B1, both these inputs we have to pass through the XOR gate, we will get G1. Then to get G0 we have to do B1 XOR B0. There is a B1 line, there is a B0 line, we have to pass through a XOR gate and we will get G0. So B3 B2 B1 B0 are binary number, and G3 G2 G1 G0 is the gray code number. Okay, now coming to the next part, gray code to binary converter. Okay, so this is actually G3 G2 G1 G0 is the gray code, so B3 B2 B1 B0 is actually the binary number. Okay, so here I have given an example 1010, and this is actually the binary number. So how we will do this? First of all, first process is same, whatever the G3 you have to directly write for B3 also. Then to get the B2 you have to do the XOR between, we have to take B3 and G2 for XOR. So B3 XOR G2 we will get the B2, and for B1 B2 XOR G1, and for B0 B1 XOR G0. So this is already written, B3 for B3 directly G3. Okay, for B2 B3 and G2 XOR. Okay, for B1 B2 XOR G1, B2 XOR G1, and for B0 B1 XOR G0. Now coming to the circuit diagram. Okay, so here G3 G2 G1 G0 are the basically gray code, and B3 B2 B1 B0 are the binary code. So G3 we have to first directly write for B3, so directly one line is there, it is B3. Then we have to do the XOR between B2 and G2, and we will get B2. So B2, this line is coming from, this is actually same for G3 and B2, so this line is taken, this is for B3 and another is G2, so both these inputs are passing through the XOR gate, we will get B2. Okay, then next B1 for B2 XOR G1. So from this we have to take the line, this is B2 and this is another line for G1. We have to pass these two inputs through a XOR gate and we will get B1. Okay, then next for B0, B1 XOR G0. So this is the one input from B1 and another input for G0 passing through a XOR gate, and we will get B0. Okay, so these are the conversion process of gray code to binary code. Thank you so much. Keep watching. If you have any doubt, then give me this doubt in the comment section. I will try to solve all your doubt. Thank you so much.